Hello and welcome to the lecture series on 8051 microcontroller. In this lecture, we will be discussing one program written in simulator MCU 8051 IDE. So I have already written a program. So let me copy it from here. I had already written it in Keel Microvision 5. Now I am copying it into the MCU 8051 IDE. So after copying it, I need to save it. So I can save it. Okay, just let me name it any name. So okay, so ADF. Okay, and I want to add this to my project. So this is the program. Let me explain it to you. What exactly is the program? So this program is basically to show the working of external interrupts INT0, INT0 and INT1, and we would be turning on and off the LEDs that are connected to port 0 and port 1 using interrupts at INT0 and INT1 respectively. So before simulating this program, let me just tell you what is happening. So ORG0000H, it tells where the program should start. Then LJMP main, it tells that program should move to the location main. So at main I have written set b tcon dot 0. So tcon is timer control register, but it is also to control the interrupt occurring in 8051. So you can see here the lower 4 bits of tcon register are basically for controlling the interrupts. So IE bit is basically to enable the external interrupt, and IT is basically it tells whether the interrupt should be acknowledged when there is a transition from high to low at the pin INT0 or INT1, or there is a low signal at these pins. So if I'm setting it to 1, then that would mean that when there is a transition from high to low, then it would be acknowledged as an interrupt. And sorry, this one IT. And similarly, if it is set to 0, that would mean that a low signal at INT0, here INT1, would result in an interrupt. Okay, so tcon.0 and tcon.2 has been set to 1. This one and this one. That would mean that the interrupts, external interrupts, have been enabled. Then move IE85. IE is interrupt enable register. This is also an SFR, and you can see here IE is here. And basically 85 means I'm setting this EA, and I am also enabling the external interrupt EX1 and EX0. Okay, then I'm making the ports 0 and port 2 low. All the pins of port 0 and port 2 are made low by these two instructions. Then SJMP instruction, basically this is a infinity loop, so it will go on executing until there is some interrupt. So when there is an interrupt at INT0, then the control moves to the location, this location. So you could see here just wait a minute here. So for INT1, this is the ISR, and for INT0, this is the ISR. So when INT0 interrupt has occurs, the program control moves to the memory location 0003H, and here I have written P0. I'm moving this value FF to P0. That means I am setting all the pins of P0 to 1. So the LEDs that are connected to P0 basically will be turned on. And then in the next step, I am basically loading R0 with value FF. And this is done basically to allow this pin, the LEDs to be in on position for some time. So then I'm using DJNZ and R0. That would reduce R0 in every instruction of DJNZ, and we'll go on evaluating this and decrementing it until it is reduced to 0. And for that duration, the port P0 will be FF, will be having FF. That means all the pins would be high. So as soon as R0 becomes 0, then the P0 will be loaded with 0 value. That means now all the pins are at 0 state, so LEDs will turn off. Then RETI basically returns the control to the main. And similarly, if there is an interrupt at INT1, then this is the ISR written here. P2 will be loaded with FF and R0 with FF. And again, R0 is checked whether it is 0 or not, and it's decremented. And this process will go on until R0 becomes 0. And this is to ensure that the LEDs that are connected to P2 port are on for some time. Okay, now let's start doing the simulation. So for simulation, I have to click this start simulation button. Okay, yes. Okay, now I can just press the animation run also is there, then step input button is also there. So both ways I can do it. So I will do step-by-step execution of the instruction. So when I press a step here, so the program moves to main, and tcon register, the lowest bit will be set to 1. So tcon, you could see here it is 00 right now. So when I press step again, then it has become 1. And similarly, when this is executed, then the second pin, basically the third pin, will become 1. So that means if I press this again, it becomes 05. And then P0 and P2 will be reset. So P0 and P2. So P right now they are all 1. The pins are all 1. So when I press step again here and then again, so again, so these two ports have now reset. So all the pins are now 0. So any LED connected to the pins of P0 and P2 will be turned off. And then if I press go on pressing this, so nothing will going to happen because the execution will go on in this line. So what I have to do now, I have to simulate an interrupt. For that, I will be basically using one interrupt. So I have to go to this virtual MCU, and then there is an interrupt monitor here. I have to click this, and now you could see that I have a window wherein I have the option to now simulate any interrupt I like. So I am interested in basically simulating the interrupt at pin P 3.2 and pin 3.3. Basically they correspond to INT 0 and INT 1 interrupt. So I will try to do that. So for that I have basically to just see, I have to animate the program. Okay, so the program running will continue, and I will show you when I press the INT0 button how the program control moves from this point to the ISR. So I'm pressing animation here. Okay, so now the program is running. So you see here it's running now. Okay, but it is moving in this loop. This is an infinity loop. Okay, now let me use the interrupt, and let me put it here. Okay, so that I can observe R values or not values. Okay, now let me introduce an interrupt at external interrupt 0. So as soon as I press this, just see, now this R naught is decreasing. Okay, so why it is decreasing, you see now control has moved to this point. So the ISR is being executed. Okay, and one more thing you would observe here, that now after the execution it has now come back to this point. So this green line basically tells where the execution is taking place. Okay, so let me now click the external interrupt 1. So again you could see here are not loaded with value ff, and then it will be decremented. Okay, and one more thing to observe, that now p2 will become 1 1. So just see here it becomes 1 1 p2, and r naught is now reducing, and once it becomes 0 0, then you will see that p2 will be reset. All the pins of p2 will reset. Yes, see here. So that means it has serviced uh, the interrupt. Okay, okay, fine. So this is how we can use this simulator for our purpose. And the good thing about the simulator is that it's quite friendly, and you can just use it in a very in a way you want. Okay, and all the things are on your screen, and you just can observe all the things going on within the microcontroller. So thank you for watching, and you can stop the simulation by pressing this stop button. Okay, so thank you again.